So our verse for today is, be kind and compassionate to one another, forgiving each other, just as in Christ God forgave you. So I just thought this was kind of fitting during this time as the quarantine is longer and longer, or we're having to go through it, and it can sometimes get harder and harder to be patient with those around you, because you're spending probably more time with your family members, brothers and sisters, or, you know, if you have brothers and sisters, you know, and it can get, you know, you guys can get on each other's nerves and stuff like that. So none of us is perfect, and we all make mistakes. So we have to remember how Christ has forgiven us, and forgive one another as well. So, but it starts off saying, be kind and compassionate. So I just want to challenge you guys to look for ways to be kind. Sometimes that means being intentional, like doing something on purpose to be kind or to be compassionate. So that's kind of my challenge for you today, is can you think of something you could do for maybe each of your family members to be kind and compassionate to them? So not just, you know, on the reverse side of forgiving them if they've done something to you, but try to find a way you could be kind or compassionate. So that's just my challenge for you today. All right, so I'm going to go ahead and I'm going to review the properties that we looked at on Friday. So we're going to go through them a little bit faster than we did before. But what I'm going to do is I'm going to kind of create a list on the board of them. And remember that I told you the book doesn't really have the examples played out very well. So if you didn't take notes on Friday, you might want to do that today, because you will need these ideas to do your homework. And yeah, so anyway, the general idea of the fundamental transformation of proportions is that since proportions have size relationships, they can be manipulated as long as they are manipulated in consistent ways. So they can be, like, you know, transformed and manipulated, but they have to be done. That has to be done consistently, because there's a relationship of equality by a certain size factor. Okay? So, and what has been done over time is people have figured out, well, what are these different ways that they can be manipulated? And that's what we're trying to learn. Okay, so we're going to see how this plays out. So if you remember from Friday, the first kind of transformation of a proportion, so just TR1, is called alternation. Okay, and that's where I had these little arrows that it connected A to C. And it's just saying, if we look at our first and our third terms, so A and C are our first and third terms, I can actually take those and create a ratio out of those. And so if you look at the proportion on the right, then I change it to A over C instead of A over B. And so if I take my two top terms, my A and my C, then I have to create the second fraction with my two bottom terms, B and D, or my second and fourth terms. So alternation so I'm just going to keep a little bit of a note. I'm going to call this alternation. It's transformation 1. Okay. It looks like this. A over B equals C over D. And then if I have that relationship established of A over B equals C over D, then I can also say A over C is equal to B over D. Okay. So I'm just taking these terms and making a ratio out of it, and taking my bottom terms and making a ratio out of it. Okay, so that's alternation. So if you didn't write that down on Friday, I would suggest that you do it now. All right, then we have inversion. So our second one is inversion. And that's saying we've established that we've got a proportion A over B equals C over D. And that is, we look at the second term is to the first term as the fourth term is to the third. So we're looking like top to bottom on in these fractions. And so the way that I can change this by alternation is by flipping. So inversion is our second transformation, and it's kind of just a flip. So if we look at, we're going to be flipping those terms. And so we end up with B over A equals B over C. So while I write it, if you haven't written this down, you're going to want to know what inversion is. It's transformation 2, so TR2. And remember, we always have to establish what our pattern is. Our original pattern is A over B equals C over D. And then for inversion, I'm looking at these as ratios, and I'm just flipping them. Okay, so then I end up with B over A equals D over C. And one of the things that you can know that this actually works is that, remember, proportions can be checked for validity, that means if they're true, by cross product. So in the original one, I have A times D, so AD, and then would be B times C. So A times D has to equal B times C. Well, if I look at these cross products, A times D equals B times C. I still have the same cross products. So therefore we know that the proportion is still really technically like the same, it's still equal. So that's inversion. Just inverting means like to flip. All right, the next one is composition. It uses addition. So it's commonly called composition, so I'm gonna call it composition. So it uses addition, I'll put a little plus sign there. And this one is transformation number 3. And does anybody remember how this one looks? Maybe you guys can tell me. I start off, I've got the if statement, if A over B equals C over D, what's the then? What does composition say is okay?
A plus D over B equals C plus D over D.
Yeah, so I have to have my original, this is my if. So if I have A over B equals C over D, then I can say A plus B is, so the sum of the first and second terms are to the second term, B, as, or equals, C plus D is to D. Okay, so I can add my two, my first and second, and keep it over the same denominator, and I can keep that equal to the sum of my third and fourth terms and keep it over to the same denominator. Okay, so that's composition, transformation 3. Now there was a corollary to it. So there's what we call a composition corollary. Okay. And we just called it TR3-1. What did the composition corollary say was also okay to do with a proportion? There's something similar, but slightly different, that also holds true. Okay, well, let me go to that slide. This was the composition one originally. But the corollary, we still start out with the same thing. If we have A over B equals C over D, remember corollary is just kind of like a next step kind of thought, so we don't need extra proof of anything. Okay, hold on, I see a chat here. The whole app is sideways for you, Jacob. Why don't you leave it on anyway? It's not going to kill me to see you sideways. I'd rather be able to see you and know that you're trying to say something. Same Colton too, I can't see you. There we go. All right, perfect, thanks. Okay, so let me go back into the play mode here. All right, so the addition corollary. So here we have, we add the numerator and denominator and keep it over the original denominator. We add the numerator and denominator of the second ratio, and we keep the original denominator. Does anybody remember how it changes a little bit? It's really similar to this. There's one small change. Okay, it's okay. I'll help you guys out this time. All right, so the only difference is I can use the numerators as my denominators. I can still add the numerator and denominator, so I can say my then would be a plus b. The sum of a and b is to the first term, a, as long as I keep that same pattern. If I'm going to add the numerator and denominator in the second fraction, the second ratio, if I'm going to do c plus d, and I compared it to the numerator, then on this side, what do I need to put c plus d over? How would I finish that pattern? If a plus b is to a,
Over C.
yeah, over c. So then I can use the numerators both as the denominators. It's okay to do as long as I follow the same pattern. People have found and been able to prove that this would hold true. If we plug numbers in here, we could go ahead and we could prove that this is true. All right, so that's the composition corollary. So I want you to remember that we can do this whole like transformation with addition of adding the numerator to the denominator, and then one of them I just keep the denominators, but then the corollary is I can still add the numerator and denominator, but I use my top term as my denominator for each of them. It's just how it changes. So that's one of the patterns. All right, then I have let's see, we'll go through the slides here. So that's the then statement. So we can add a and b and keep it over a. We can add c and d and keep it over c. So that was a corollary. Now the next one has to do with subtraction. I'll put that up here. And the subtraction one is called decomposition. So you can kind of think of like, decomposing is taking stuff away. So decomposition. I'll put a little subtraction sign. This is transformation 4. Now the decomposition transformation is kind of similar to the addition transformation. Anybody want to take a stab as to what the then statement is? So I have to have that if a over b equals c over d. That's my initial relationship. Then what can I say? How would I write the transformation? Because the property says the difference of the first two terms is to the second term as the difference of the last two terms is to the fourth term. How would I write that?
A minus b over b.
Okay, good. A minus b over b is to what? Somebody else. Can somebody else do the other side?
C minus d over d.
Okay, c minus d over d. So I take these two terms, first and second, I take their difference, which is subtraction. And then I keep the same denominator. And then I take my other ratio, subtract the two terms, c minus d, and keep the same denominator. Now remember, that is a true proportion. If I put numbers in there, and I started off with a true proportion, a over b equals c over d, then I'd be able to show that this was true by subtraction. There's also a corollary with this one. Okay, so I have a decomposition corollary, and it follows the same as the composition corollary. So this would be subtraction, and this would be transformation 4-1. It's a corollary. So decomposition corollary. So if this follows the same pattern as that addition corollary did, can you guys figure out? We start off with A is to B as C is to D. And what is my conclusion? Okay. The wording says the difference of the first two terms is to the first term as the difference of the last two terms is to the third term. So how does that change it? If I say the difference of the first two terms is to the first term, how would I write that? The difference of the first two terms is to the first term.
A plus B over B.
Good try. It's still difference. What does difference mean?
Subtracted.
Right? Yep. So it's still A minus B. But it says the difference of the first term to the second term is to the first term. Well, what's the first term in this sequence? Is A
over B.
Okay, there's only one letter is the first term. Which one's in the first term position?
A.
A. So A is our denominator in this case. Okay. So when I do this, I find the difference between these two terms, and then I pick what was the numerator, and I can make it my denominator. And that will hold true if I do the same pattern on the other side. So who can follow this same pattern but use it with C and D? Somebody else. Follow that same pattern, but apply it to the ratio of C to D.
C minus D over C.
Right, C minus D over C. So the only difference between the corollary and the original transformation is just the is that the numerators now become our denominators. Okay, so that's how those corollaries come into play, is that the property still works as long as we are still taking the difference between the first two terms, and then we follow the same pattern and divide by what was the original numerator. So that will work as well. Then our last, or let me go through the slide. You can see it. So make sure you're writing this stuff down, like I said, if you didn't on Friday, because you're going to need to use these. So that's what that one looks like. The last one, transformation 5, has to do with powers and roots. So we're going to call this powers and roots, also known as TR5. And it says if four quantities are in proportion, so that's our if, so we've got A over B. If A over B equals C over D, then I can say like powers or like roots of these quantities are in proportion. So can anybody give me an example of what that would look like?
Like, would it be A squared over B squared equals C squared over D squared?
Exactly, good job. A squared over B squared equals C squared over D squared. Okay, can anybody else give me another example? Let's put a couple of them up here. This one, there can be like tons of examples. So let's get a couple up. What else could we do?
A cubed over B cubed equals C cubed over D cubed.
Yeah, A cubed over B cubed equals C cubed over D cubed. Okay. How about with roots? Those are with powers. What's an example I could write with a root instead? Okay, well, what are some examples of different roots that we use in math? Like, one of them is a square root. So for example, if I put like the square root of A, I started it that way, how would I have to finish off the proportion? If I start my pattern by taking the square root of A, how would the rest of it finish? Oops. So can I like do something like this? Can I put the cubed root of B, because B is down here? Can I do like, does this work? So would that be true according to this? Oh, I keep doing that, sorry.
Yep.
So the rule says that it has to be like powers are in proportion, or like roots. Are all these roots alike? Like, is this root like this root, like this root, like this root? Are those the same? No. Okay. So one of the things you have to make sure you understand with this last transformation is that if I'm going to keep things in proportion, these all have to be the same exact root. So if I'm going to keep this property true here, I would have to just use the square root of A, B, C, and D in all of the respective positions. But if I wanted to use like a cubed root, I can do that as long as I take the cubed root of everything. Okay, I can't change my roots within the proportion. I can only use the same root of all of them. So it would be okay to say the cubed root, cubed root of A over the cubed root of B equals the cubed root of C over the cubed root of D. Okay, that would be okay. Let me just see. Okay, I want to make sure you guys can see that. So let's take a look at all of our properties then. You guys see my screen bigger now? Should be able to. Okay, so let's do a quick little review. Alternation from the beginning, starting from the top, is where I have my proportion set up. I take my first and my third term, and I make those into a new ratio. And I take my second and fourth terms, and I make them into a new ratio. They will still be equal. This is still an equal proportion because my cross products are AD and then BC, and here I have AD, BC. So it works. My inversion. So transformation 2 is inversion. So same original starting proportion, A over B equals C over D. Well, inversion just means to flip it or like take the reciprocal. So as long as I take the reciprocal of both sides, I can say B over A is equal to D over C. I just have to do the same thing. Or with composition, it uses addition, and this is transformation 3. If I have A over B equals C over D, I can just add the denominator of this ratio to it, keep it over its denominator. I can add the denominator, which was D, so C plus D over D. That will keep a true proportion. The corollary is that I can still add the numerator and denominator, but I could also use the first term as the denominator, as long as when I add the numerator and denominator, the second time I have a ratio, I keep what was the third term as the denominator. Okay, so that's transformation 3-1 because it's a corollary. Then for decomposition, decomposition means we're just taking things away instead. It's transformation 4. So I can subtract my numerator and denominator as long as I keep my denominators the same. Again, on this one, I subtract my numerator and denominator, C minus D, and I keep the same denominator. Then the corollary is instead of using the original denominators, I'm going to use the numerators as the denominators. Still to do the subtraction, with A over B minus, or A minus B over A, C minus D over C. And then the powers and roots transformation, number 5, is just that if I have a proportion, as long as I do the same power to all of them, or the same root to all of them, I won't change the proportion. So this is the summary of like legal rules for manipulating proportions. Okay, they still keep their original relationship in this way. So now what we want to do is we want to go to a place where we're starting to use them. So I'm going to go back and share my screen. Let's see. And we're going to go through an example. So I'm going to finish that up. Okay, so quick summary for some of you who like it in words. It says the roots and powers ones you can manipulate proportions by any power and root as long as you do the same power or roots to all the terms. That's one of our rules, just in words. Another rule is you can change the order of terms in a proportion as long as you take the first and third and make them a ratio equal to the second and fourth. And that was alternation. Or you can change the order of terms in a proportion as long as you take the reciprocal of each proportion. That was called inversion. So that's the flipping. And you can either add by composition or subtract by decomposition the numerators and denominators of one ratio as long as you divide consistently by either the numerator for that ratio or the denominator for that ratio. And you have to follow the same pattern for the other ratio. So those are them just summarized in words. So one of the things, the most basic things right off the bat that we need to make sure that we can do is that we can transform any proportion in all of these ways. Okay. So what I'm going to do is I'm going to take my if statement, instead of a over b equals c over d, we are going to change it to 3 over x equals 12 over y. So I'd like you to write down this example, and you guys are going to be chatting some of this to me as well. So have a piece of paper and a pencil ready just so you can write it down, and then you can type it to me or whatever. So our original proportion is 3 is to x as 12 is to y. So what I'm going to do is I'm going to go ahead and I'm going to erase all of the stuff underneath my headings. So I'm going to keep these because what we're going to do is we're going to transform this starting proportion in all of these different ways. I just need to erase this. Okay, you can start thinking about it if you're ready to go, and because we will start with alternation. So the first thing that comes first, though, is you're going to want to write this as a fraction. So a proportion with fractions in it, because it's a little easier to work with. Our minds are usually a little bit more attuned to looking at it that way. So if I have 3 colon x equals 12 colon y, how do I write that in its fraction form?
3 over x equals 12 over y. Or other way around, doesn't matter.
Okay, so 3 over x. Okay, so make sure you write that down. That's like what we're starting with all the time. 3 over x equals 12 over y. That's our original. Okay, that's like what I was using as like the a over b equals c over d. So our first one that we are going to do is alternation. Okay, so we're looking up here. So by alternation, I'm going to do the same thing. I'm going to write 3 over x, because that's my original one, equals 12 over y. Now, but what did alternation say we could do? What did alternation say we could do?
We're like,
Which B and C, the second and third term.
Okay, second and third terms, no, we're supposed to look at alternation goes straight across. Okay, we can think of these as a pair. Okay, because first and third are like alternates. That's kind of how you can think of it. First and third are like alternates. So I'm going to take this top pair. So as you're doing it, you might want to label alternation and circle the top pair. And I'm going to change that into its own ratio, 3 over 12. Can you guys see the blue?
yeah, is this like a little different than like what we had for the like slide?
What do you mean? It's a different problem. Yeah. It's a different problem. But it's the same principle. Alternation uses the first and third term, and it changes it to one ratio. So it's the same.
Okay.
Right? So then I take the second and fourth terms, and I can box those, and I'm going to create a fraction with those. So it's going to equal x over y. Okay, so 3 over 12 equals x over y. So that's alternation. So if it's kind of like, remember, alternates are like, you go start with one and you skip one. That's what the first and third terms.
When you change it to 1/4.
For right now, I'm not gonna like reduce anything. Right now, we're just transforming. Okay. You could though, Gilbert. You're right. We could reduce this to 1/4 equals x over y. We don't have to do that right now. That's not like the end goal. But I'm glad you said that. You could. It would be okay to do that. Okay, so now this same one by inversion, 3 over x. Markers are like, I need to go get some things again. Let's see if this is better. That's better. Okay. Okay, can you guys see this screen? 3 over x like that?
That's better.
That's better? Okay. So we start with the same original ratio. 3 over x equals 12 over y. Now by inversion said, ultimately, I could just flip it, as long as I do it to both. So then what would be my result? What would be my transformation if I do this by inversion? What's the new proportion? Still equal, but how does it look different? Yeah, I'm just.
Do we type it to you, or do we tell it, like just tell you?
Tell me.
It would be x over 3 equals y over 12.
X over 3 equals y over 12. So that's a new proportion by inversion. It's just, it's equal, but it's just, it looks different. All right, sorry, I just lost Jacob. Looks like we lost somebody else. All right, so then composition is the one where we use addition. Start off with the same original proportion, 3 over x equals 12 over y. Now, by composition, how can I transform it? What is it? Remember, the idea is that I could add the numerator and denominator of one ratio. So how would we show that? Adding the numerator and denominator of one of the ratios. How about Colton? If I add the numerator and denominator of one of the ratios, what do I write? Did you hear me, Colton? Oh, your mic won't work? Can you type it? Okay, yeah. All right, so we're trying to figure out what can I add together by composition here. If Colton can type this. Oh, okay. You can't see the board, like my board. To share. Okay, hold on a second. Stay there, it's maybe better. Okay, so my ratio is 3 over x equals 12 over y. Can you see it now, Cole? Okay. All right. So what by composition though is where we want to use addition. Okay, so remember it's saying that I can add my numerator and my denominator. Okay, so since I can't hear you, Colton, I'm gonna have to kind of go through it a little bit. So I can add my numerator and denominator, so I can say 3 plus x, and I always keep the same denominator over x. So that's how I would transform this ratio on the left. Now that has to be equal to the same kind of transformation to this one on the right. So who can tell me how would I transform my ratio on the right in the same pattern? Following the same pattern.
Equals 12 plus y over y.
Yeah, it would equal 12 plus y over y. So by composition, I could transform that original proportion to something like that, and it would still stay equal. It would still have the same value. Okay, now what about the composition corollary? I still am going to start with the same proportion, 3 over x equals 12 over y. How could I transform this using almost the same pattern, but there's that one tiny little difference about
It would be 3 plus x over 3
okay, good.
equals 12 plus y over 12.
Okay, good. 12 plus y over 12. So notice the difference was the denominators. Okay, what I changed, or what Izzy changed, was instead of using that second and fourth term as the denominators, she used the first and third terms as the denominators. And that would be a true and correct transformation of proportion. This proportion would still be equal to this right here. Okay, so let's do it by decomposition. By decomposition, we're still going to start with the same original proportion, 3 over x equals 12 over y.
Can you move your camera to the right more?
Yes.
Thank you.
How's that? There, I think you can see it now, right?
Yeah, that's good.
Okay, good. Okay, so decomposition. Decomposition means like, do I use addition, subtraction, multiplication, or division?
Subtraction.
Subtraction. Okay, so by decomposition then, how about Jacob? Can you tell me how I'd rewrite this one? How I'd transform this one?
Since my video was sideways, your guys' video was sideways, I couldn't see the board or anything you would screen share for the first 40 minutes.
Oh, okay, that's a bummer.
That's what I was trying to tell you.
Oh, I didn't get it then. Okay, I didn't understand. All right, can you see it now? Is it okay?
A little.
Okay.
And also, could you send like some of the notes or just like a couple of the methods or where I could find them at least?
Sure.
Thank you.
Yeah, I think what Jacob, the best thing to do is I'll post the video and it's for you to scroll through the screens. Like,
Okay.
slide through it. You don't have to watch the video, but just like pause it and scroll and like look at the board. And that's probably the best way.
Okay, thank you.
Okay, so that means that we're going to need somebody else to help them out. So decomposition. Decomposition.
3 minus y over x. 3 minus x over x equals 12 minus y over y.
Okay, yeah, so we just use subtraction for decomposition, 3 minus x. So we're subtracting the numerator and denominator, keeping the same denominator, setting that equal to numerator minus denominator, so 12 minus y, keep the same denominator, so it's over y. So this is the transformed proportion by decomposition. How about the decomposition corollary? We still start with the same original, 3 over x equals 12 over y. How am I going to transform that by the corollary to decomposition?
3 minus x over 3 equals 12 minus y over 12.
Yeah, 12 minus y over 12. So hopefully, I hope that you guys are starting to see the patterns here. This is really all about patterning. So this proportion, if we were to plug the same numbers always in for x and y, or the unique numbers, would end up making this true. So this proportion would have the same value as this one would. Okay, by powers and roots. Again, our original proportion is 3 over x equals 12 over y. Okay. So in this case, if I wanted to show, let's show one with like cubed. If I'm going to cube something, how could I write this? How about Gilbert? I haven't heard from you. Can you tell me how would I write this by transforming it using powers and roots if I wanted to cube or use like to the third power?
Would it be like squared or something?
Well, it'd be cubed, so that's the third power.
Oh, that's third. Yeah. So then like 3 with the to the third power equal over x to the third power or something. I don't know. Equals 12 to the third power over y to the third power.
Sure. Okay.
Cool.
All right. So then, how about let's see. Jacob, can I put you on the spot? Even maybe if you can't see it, can you see the original proportion here? Can you see that, Elena? 3 over x.
A little.
Okay, so 3 over x equals 12 over y. If I wanted to use square roots by transforming it with a root, like a square root, how would I write it? Or maybe you can just explain it to me. You don't have to use the correct letters and numbers.
Well, since it has to be square roots, wouldn't you take the square root of 3 and the square root of 12?
Right, I would.
So that would be 9 and 144, respectively.
That's, oh, okay, hold on a second. I think maybe I confused you. This is already transformed. Okay. That's a different one. But when we take the square root, I'm talking about like this symbol, like the square root of 3, like that. Can you see that?
Mm-hmm.
Yeah. So we don't have to square it. We just, we have to take the square root of both of them. So square root of 3 and the square root of 12. What else do I need to do to finish off that proportion?
Square root the x and the y.
Good. Okay, the square root of x over the square root of y. Okay, so that's transforming this same proportion by a root. Is just that if we're going to do it by a root, we have to use a common root. Okay. I think, let's see, what I'm going to have to do. Hold on, I just need a moment to modify something here. Yeah, I think we're gonna have to hold off another day on the homework because this whole concept is taking quite a while, which is okay. Proportions can be kind of tricky, and so I'm trying to gauge when I plan my lessons how it's gonna go, but it's taking a bit longer, so I don't want to rush through it. So I'm actually gonna give you guys a free pass again tonight because I don't want to have crash and burn on the homework. We're still not quite ready for it, and that's okay. I'd rather take it at a speed where we can handle it. So I'm going to omit the homework, and I'm positive tomorrow we will be ready for the homework. So we're ready to go into like all the main examples. This was kind of like a pre-example to the main examples. We needed to go through transforming one proportion in all the different ways and get a feel for that, okay? So what I would like to say though, is that I want you to know, if I say alternation, I want you to know these, that I'm looking at the first and third terms and I'm gonna make them into a fraction. Okay, I want you to know that if I say composition, I'm talking about adding the numerator denominator and setting them over the original denominators. Okay, I want you to know those. So even though I'm going to cut the homework for tonight, if you can't remember those, I want you to look through your notes and get those in your head. We're gonna need to use those kind of quickly and fluently to do what we're gonna do in the problems coming up, Okay, so your homework would be to study these if you need to. You know yourself, and so make a good decision for yourself. If you're not getting it at this point even, maybe stay at the end and I can talk through it a little bit more with some of you before we jump into some more difficult examples tomorrow. Okay, so if you're fine with everything so far, I'm gonna let you go. If not, hang on and let me know that we should talk just for a few more minutes. Otherwise, have a good day.